Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Umwaka, and I am your instructor. Today, I will be showing you the structural design of 4-story reinforced concrete building, having different foundation levels. Now, the reason for the difference in foundation level is because of the topography of the site. Some part of the site is having a level of minus 3.8 meters from the road level. So in the course of that, the client tends to introduce a basement so that it can be able to fit in on that area of the site having a minus 3.8 meters down. Okay, that's fine. So in this building right now, you will be performing the structural design of this building. So some part of the building will be 5-story, while some parts will be 4-story. Now, the structure is very, very unique because most times, most engineers might not be able to encounter this during their lifetime. But if you have this idea, when you encounter this kind of issue, you'll be able to resolve that issue without any much delay or stress. Okay, that's fine. Now, we have already done the part 1 of this video where we focused on the structural framing, which is the part 1. And the part 2, we talked about the structural paneling, which will deal with the beams arrangement and also the slab arrangements. While the part 1, we dealt with the column positioning. Now, these two parts, which is the part 1 and the part 2, they are very, very important when it comes to structural design. Knowing that the framing of the structure is the key important part when you're performing your design of your structure, because that is the time you need to understand how you want to withstand the loads, how you want all the members to be connected, okay, and the stability. Okay, now on this part 3, we will be performing the structural modeling. So if you miss the part 1 and the part 2, I would advise that you should go and watch those part 1 and part 2 before you continue on this part 3. Now, our mission is not just for us to make video for you to watch. No, we are here to train the future civil and structural engineer. So please make sure you watch the part 1 and the part 2 of this video before continuing to watch this part 3. Else you might get lost on the way. Now, before we begin, please, I would like you to like this video. Okay, now the reason for you liking this video is because the more you like our video, the more YouTube will help to recommend this video to other younger engineers searching for these things you are also watching now. Now, please like our video, and also if you have not subscribed to our channel, please subscribe to our channel. And if you are an old subscriber, you have been here for more than 1 year, I would advise you join Ekidel membership here on YouTube, because on that membership we structured all our videos beginning from all the levels of engineering when you're a student, final year student, junior engineers, up to senior engineers. And we make these videos based on those levels, knowing that if a student is watching a video on flat slab design, he will be confused, right? So in the course of that, just to avoid those issues, we have created different levels, and we have structured all our videos on those levels, just not to avoid anyone to get confused. Okay, that's fine. And to access this membership, you can click on the join button, which you're seeing there on your screen. Join button. Okay, now most countries cannot see these join buttons because YouTube has not yet activated the join buttons for the countries like Uganda, countries like Kenya, countries like Tanzania, and so on. But for other countries that can see this join button, Nigeria and all that, please join that. Now, if you can't see this join button to join our membership, please just chat us up on WhatsApp. We will have our WhatsApp number down on this video description, and we will guide you on how to do that. Okay, that's fine. Okay, so right now let's now begin for the structural design of this building you are seeing here on my screen. Now, also, if you want a one-on-one mentorship training on Ekidel, please click on the link below and then we will take it up from there. Okay, that's fine. Okay, let's now begin now for the design and modeling of this building. Now, we are going to be exporting this building you are seeing here to the software for our structural design. Now, if you look at my screen now, I've already brought out this software here. Okay, so right now we are going to import this CAD file into this software for our design. Now, I've already created a template, as you can see it here, for Storey building, and the code we are using for this design is Eurocode. Now, irrespective of the code I'm using, you can also use your own code, BS code, Indian code, ACI code, and all that. It doesn't really mean. All right, but the whole concept is for the loading. Okay, that's fine, and the modeling. So you can choose your own code and then follow me up on this. Okay, that's fine. So with this now, if we want to import the DSL file that we did on the part one, sorry, on the part two, we'll then come here on this place that says external reference join. Now, if you're using a lower version of this Protastructure, you might not be able to follow us up very well. That's because of the interface of this newer version of this software is different from 2018 and all that. Okay, so I'm using 2024 version of this software. That's because this version will help us to like model the lift bit. Okay, that's fine. So with this now, I will then come here and click on this place that says what external reference drawing, and then wait for it to display the next interface. Okay, that's fine. So on this place now, I'll come here and say what add DSF. So on this now, I will then go to my desktop here, sorry, my computer, and locate where we saved our what DSL file. Knowing that that DSL file was saved on our client's folder, it's local, that's fine. Yeah, this is the file. I'll then come here and do what and click on what open DSF. Okay, now on opening DSF now, it is trying to import the DSF into this interface. I can see that our screen still looks what empty. So if I come now and check on this active right now, active DSF here button here, which is here, you will see now that we now have our trace of our drawing here, but no structural members is yet imported, just as the column and all that. So for us to now import the columns that we performed on our GA drawing and also import the grid lines to convert them to axis, we then come now and then click on what import here. Okay, import. Now, on clicking on import now, this interface appears, knowing that we set grid lines and column on our part one where we're doing our structural framing. I will then come now and click on what import. Leave everything else here as default and then click on what import here. Now on this now, it will start to convert those polylines into columns and those grid lines into what axis, which you're seeing here. Now when this is completed, this close button here will be active. Okay, that's fine. But until then, let's wait for it to be active. Okay, that's fine. So as you can see right now, it is now what completed, because you can see that our close button now is now being able to highlight. Okay, so I'll now come now and then click on what by clicking on what close button here. So on this close button now, you must make sure you click on what OK, else you will lose everything. So come here right now and then click on what OK here. So on this OK now, you can now be able to see that all our grid lines are now in what axis, as I see here, axis, and then we also have our what column members, column this and all that. Don't worry, I'll show you how to arrange your column, and then the column naming will start from column 1, 2, and 3, and not this way it is showing here. Okay, that's fine. So if I now go to my 3D view now on this place here, you will be able to see that we only have our structural columns and all that. That's because that is what we imported from the DSL file. Okay, now we will now begin with the beam insertion. Okay, that's fine, to model the beam. Okay, so you can see that we only have our columns, as you can see it here on my screen. Okay, that's fine. So with this now, let's now go back to the plan view. So on this plan view now, we'll then begin to model the structural beams. Okay, that's fine. So on the structural beam now, I will then come here that says what modeling here, and then click on the concrete beam. Okay, now if you're using older version, you won't be able to see these two options, coupling beam and normal beam. Okay, now this coupling beam are beams used in between a reinforced concrete walls. Okay, I have done some buildings in Canada that was earlier this year, where we introduced coupling beams because it was a precast structure. Okay, so I'll have to use a normal beam. Okay, so if you're using older versions, you won't see these two options. Okay, that's fine. So I'll come here right now and then click on what normal beams here. Now on the normal beam now, it will display a dialog box here on my side here. Now on this place now, I will have to impute what the width of my beam and the depth of my beam, which is the h. Okay, leave this e as default and all that. We are not dealing with this for now. I'll explain this later. So on this now, which is the width of the beam, now before you choose your width of the beam, all right, the width of the beam is, you have to assume it. Okay, assume, knowing that design in a real sense, it based on what assumption. You have to assume your sizes. Okay, now after your assumption, we now perform the structural what analysis to check if to be able to transfer the load, the weight which you have loaded on that structure to the members. They will now begin to do what, perform like the design. Now that design stage is to check if the structure, if the sizes of the members, which is the beams and columns that we chose, is able to carry the weight or the load imposed on those, on the structure, that's on those members. Okay, that's fine. So with that now, I will have to assume the width of my concrete beam as what, 225. Okay, 225, which is the width of my column, as you can see it here, for it to be able to fit in together. And then for the depth of the beam, I will take 450 as my minimum depth of floor beam, knowing that BS code or UO code states that the minimum depth of floor beams, it should not be less than what, 450 millimeter. Okay, that's fine. So with that now, once I input my width and my depth, okay, the next thing I'll do right now is now begin to do what? It's now begin to insert my beams. Okay, now to now insert our beams now, knowing that we have already performed our structural framing on the AutoCAD, so we have already known how our beams are going to run, as you can see them being traced here. So all you need is just do what is to follow what is happening here, as you can see the trace here. So with that now, I will then click on this place here, okay, and then click here. Okay, now we have now inserted our first beam, as you can see it here. Okay, this is beam 1. Okay, that's fine. So with that now, I will then come again and begin to insert the next beam. I'll just click on escape key to make it faster. Click here, okay, and then click here. That's fine. Okay, that's fine. And then continue again by clicking this other side here. I'll then click here and then continue again to click here. That's fine. So you can see right now what I'm doing right now, just to be tracing what we have already done. Okay, that's why it is good to perform structural framing very well. Okay, that's fine. So I'll come again now, click on this place here, trace up to this place I have an end here. That's fine. And again, continue again, click on this place and then move again from here now up to this very place here and keep here. Okay, so yeah, you just continue to do these things until you have traced all the beams on, as you're seeing here. So let this trace line you are seeing here that looks as if like it's a gray guide you on where to insert your beam, because we have already brainstormed all this before when we are on the part 2 where we did the structural framing paneling. Okay, and all that. Okay, that's the beams and the slab paneling. Okay, arrangement. That's fine. So with this now, let this now guide you. Okay, so by doing this now, I'll have to pause this video and follow up all these things I'm doing here by tracing all these and make sure I insert my beams. So make sure you follow this 10 step, okay, and all that, to insert your beams too. Okay, that's fine. So if you want to get the CAD file of this, check the link down below and get the CAD file and follow up. Okay, that's fine. So with this now, I'll do the same thing here. So with this, I'm going to pause this video right now and then continue when I've traced this part of the structure, and then continue again to other part. Okay, that's fine. Now, as you can see, I've inserted almost all the beams on this line, as you can see that and all that. Now, the next thing now is to insert on this other side. Now, for most people that are new here on Ekidel that don't know about beam insertion, I'll just work with you together to insert this. Okay, that's fine. So I'll back again, just come back to my beam here, click on normal beam and make sure my settings are okay here. Okay, that's fine. And then come here and then click on this place here and then insert again from here to here. That's fine. Okay, and then continue again from here, from this column now up to this very side here and stop. That's fine. So again, I'll continue again I'll come come again now, and then from here insert my bin all the way down here. That's fine. And again, continue again here. Now again, and insert again from there all the way down here. Now, if you're new on Ekidel, there is what we call Ekidel Structural Online Store, where we post most of our course videos and most of the materials that are used here for that will aid you for your design of structure. Okay, that's fine. So you can get the bio or the link to our structural online store on our bio, or on most of our videos you will be able to see some links for Stonebridge templates and other powerful softwares that we use in collaboration with this software to perform a good structural design. Okay, and all that. So and also if you also want anything about Ekidel, you can get that from our Ekidel online store. Okay, which you can see the link on our bio here on Ekidel here. That's fine. And then we also have we are also posting some videos on our Facebook page. So for Facebook lovers also, you can also be watching Ekidel's videos from our Facebook page, which is Ekidel Engineering. That's fine. So I'll come again and click here, and then continue all the way again, and then let's just hold on for that to load. Click on this place now and insert the bin to here, and then continue again from here all the way down to, let me see to this place here. That's fine. And again, we continue again from, and for those that want to join other engineers on our Ekidel global WhatsApp group, yeah, we also have WhatsApp group on where other engineers also interact with each other and shares knowledge, okay, and also help each other to solve solution. So you can also join our global WhatsApp group, which are on most of our videos on Ekidel. Okay, but if you can't find the WhatsApp group link, you can also message us on WhatsApp, and we will send you the group link or add you up to, or say, or give you the link to join the Ekidel global WhatsApp group. That's fine. Now, we don't have any group on Telegram, so if maybe someone says she joined Telegram group, that's not Ekidel. Ekidel is not on it doesn't have any group on Telegram, though we are on Telegram as individual, but we don't have a group on Telegram. Okay, that's fine. Okay, so let's just continue again to do that right now, and then let's do this right now. Escape, click on this, and continue again from here all the way down here. Okay, now after the beams, now we are now going to model the lift wall. Okay, we will also model for the doors of the lift and all that. Okay, then you can see this is the lift area. Here is a lift and here is a lift. Okay, let's just continue for that first. Model from here all the way down here. That's fine. Okay, and again model again from here all the way down to this place here. So it's very easy. Once you're done to GA, just trace what is happening there, what you're seeing here. Okay, that's fine. You can see that we are not going to spend more than 25 minutes modeling this whole building. Okay, now had it been I was not talking, I would have finished this in less than 15 minutes. Okay, but because I'm trying to explain all that, that's why you can see that we are currently at 18 minutes. Okay, plus. Okay, that's fine. Again, I will then come again and then come now, click here, and then click here too. That's fine. And again, I will then continue again, continue from there. Okay, from here now all the way down to this end. Okay, and then close it up going my left hand side from here, sorry, from here now all the way down here. That's fine. Okay, so I'll come again now and then click here and then click here. That's fine. Again, I'll then come again, click here, sorry for that, click here, yeah, and then click this other side here. Okay, click here and then click here. That's okay. And again, I will then continue again by coming here, bam, click this side and then go up again and then click here. That's fine. And then we then have a cantilever beam which we model here. Okay, and then we are going to come now, start from here, click on this place and over to the cantilever beam here and keep that. And again, you can see the triangle here which shows for cantilever, and then we'll then have to model the other beam that's connected to the cantilever beam. Okay, that's fine. So again, now we will then have to come and model. Let me see. Okay, you are done with that. That's fine. That's okay. So you can see that we have almost modeled everything. Now the next thing that's left now is now model the lift before now connect all the beams connecting with the lift. Okay, that's fine. But before then, let's go and treat up what is happening here. You can see that we have two cantilever beams here, which is not right. The small beam, the shorter beam is meant to carry a longer beam. So with this now, this shorter beam here is to be the cantilever beam that is carrying this longer length of beam. Okay, so with that now we are going to unmark this as a cantilever by taking the beam here, click on it, right click, and then come here that say mark free end the cantilever and say what both ends supported. Okay, that's fine. So with this now, this only becomes a cantilever because it's a short beam. So short beams carries longer beam. Okay, that's fine. Don't make the mistake of using longer beam to mark as a cantilever to carry a shorter one. That's not nice. It's very bad. You're going to waste resources on that. Okay, that's fine. So with this now, let's now model for this wall. Okay, but I think we still have one wall. We have not one beam to model here. So I'll come now, click on this beam, right click and say properties to open it back again, and then come now and model this here and model this too. That is fine. That's okay. So with this now, let's now go and model for the lift wall. Okay, that's fine. So I'll click on escape key now. Okay, and then cancel, close. Then come here, and then to now model our lift wall, I'll come to modeling here, click on wall. Now this wall here is a reinforced concrete wall. Don't get mistake, it's not a block wall. It's a reinforced concrete wall that has reinforcement. Okay, that's fine. And it's also designed for, okay, so it's not really typically a block or masonry wall. No, it's a reinforced wall. So with this again now, I will then come here and put in my wall thickness 225, again assumed, and then come here and then, or let me just put, yeah, assume 225, and then come here and put 112.5. That's fine. And again here 112.5, which is the half of this value here. Okay, that's fine. And then come now and then click on this place here, come again and click on this place to model the wall. That's fine. And then on doing this now, I will then come again. Okay, I'll then come again. Let's start insert, come click on this place now. Okay, knowing that you can see that we have wall opening here for door. Okay, now before I insert this now, let's just do something by measuring the opening of this, because you can see that it is at the center. I believe this should be 1.2 meters. Okay, so click on this place here and click on this place here. Let's see. Yeah, this is 1.2 meters. Okay, that means that the opening is 1.2. That's for door, to the entrance of this into this lift. Okay, into this lift. So with that now, let's now model for other part before we can now model this and make the openings. Okay, that's fine. So I'll click on this now, right click here, and then come now and click on these properties here. And again, I'll come now, click on this point here, model this other wall here and click here. That's fine. And again, I'll then come again and then click on this other side now. Okay, that's fine. Click on this. Okay, let's just see. Click on this point now and then come here and then click on this point here. That's fine. It's coming up. It's coming up. Okay, so with this again now, I'll then come now, click on this place here, and then come here and click on this other place here. That's fine. So knowing that we have opening here, which I will show you later, let's go and model the other lift on my right hand side here. So on this other side of the lift now, let's go and model that, which is this one here. So on this one now, the same thing happens again. Click on this point and also model this. Okay, now most times when you import your building plan, you might see that your columns are moving away from the center of the grid line with about, let me say, minus 1 point something meters. Sorry, 0.01 meters, 1 millimeter. Okay, you can see So we have to correct that later. You can see that. Okay, that's fine. So I'll come again now, click on this. So when you're modeling, basically you have to model for perfection. Make sure you model to perfection. Okay, don't allow all those minor errors in your modeling. Okay, else, yeah, even if it not affect the structure, but it might affect your dimension, which of course, when you have several errors of let me say 1 or 2 millimeter dimension error, by the time you accumulate it over time, you will see that you will be having a difference of about 20 or 50 millimeter or 100 millimeter difference from the actual length of the building, or that length of and all that. Okay, so it's not nice. So make sure you model to perfection when it comes to measurement. Okay, that's fine. So with that, now I'll then come now and then click here and then click on this other one here. That's fine. So with this now, let's now go and look at the 3D view for what we have just done, knowing that we still have to model some beams which are connecting to with these walls. Okay, let's just do that before we now go to 3D view. Okay, that's fine. So right now, come here, click properties here to open the beam property, and then connect these walls. Now there's a beam here connected here. Okay, and again there's also a beam on this other left hand side, okay, which is also here, that connect from here also to the wall here. That's fine. And again, we also have beam connecting beam to this other side here. So what is carrying this beam now is these 2 beams that are on both sides. Okay, that's fine. So beam can carry a beam. It doesn't really mean that you must have to use columns to carry your beam. No. Beam can carry a beam. Okay, that's fine. So with that, again, right now, I will then come now, click on this place here and click on this place here. Okay, that's fine. And again, I'll then come again, take back the property of the beam to open it back again because it has closed. That's fine. And again, click here and then click here. That's fine. Okay, that's fine. And then again, come again. This other side too. Click here and then connect to this place. Yeah, that's fine. So make sure you don't miss anything at all when you're performing your modeling. Okay, that's fine. And again, come again now. Escape, come here and then join here. That's fine. And again, let's now see our 3D view, because I'm sure we have modeled all the beams that we are meant to model. Let me see. Correct. So you can see that we have traced all the beams now to what we have seen before. The next thing now is to see our 3D view, then now begin to model for the reinforced concrete slab. Okay, that's fine. So with that, now let's now go and see 3D view by clicking on this place that's already tabbed opening here. Okay, if you cannot open this, go here and right click on this view. You will see 3D, physical 3D view. Okay, that's fine. So with this now, you can now see what we have just done so far. If I carry this my grid line downward for the sake of clarity, you can now see what we have just done so far. So we have now modeled for the beams. Okay, you can see that right now. So let's now go and open the 1.2 meters door opening for the lift here. Okay, we can do that right here on this 3D view. Okay, that's fine. So I'll make sure I am back on my story 1 because I click story 0 to be able to allow the grid line to go downward. Okay, that's fine. So on story 0 now, we then move on and then click on this place here on the wall, which is on the face. Right click here and to create what opening. So I'll come here and do what, say wall opening editor. So on this place now, this dialog box appears. I'll make sure I come here and do what, add. So on adding right now, I'll come here that says W. This W here simply means the width of the opening, knowing that it is 1,200. Okay. Now, before we proceed, knowing that the wall, this opening, this door opening is directly at the center of the wall, okay, of this lift wall. So with that, I'll not make any shifting. All I'll just do is to add the height of the door, knowing that door minimum height of door is what, 2.1. Let's assume what the minimum height of door, 2,100. Okay, that's fine. So with that, I'll leave this place as it is. Then come here and make my Y here. This Y is the distance between the level, between the slab level or DPC level to the door. So I'll come here and either make it 0, okay, and say yes. You can see that right now it's starting directly from the floor level. which is the door, knowing that door starts from floor level. But I can come and add 25 millimeter just to apply a small seal. Okay, that's fine. Okay, that's okay. Can you see right now? Then come now and do a click on what? Okay here. So on this now, a door will appear here just now. Just watch out. That's fine. You can now see the door appearing just now, which is the entrance. Don't forget, this space here is for the DPC. Knowing that the DPC for this building is what 600, although we have not yet applied that, okay? But it's just taking a default. So this place here you're seeing here is the foundation part and also the DPC part. So basically, the DPC level for the slab is starting directly around this door opening here, okay? Knowing that we left 25 millimeter just for a proper seal, okay? But you can choose to leave it at 0, that's fine, okay? So on this again now, let's now come and do here. Know that you cannot copy opening into this place, okay? You can only copy block wall opening, but not opening on a reinforced concrete wall. So we'll also create opening for these two. Come here right now, right? And then open this place here. Do the same thing again. The width is 1200. The height here from the sea level, from the DPC is, let me say, 25 that I used before, or 0, that's fine. Then come now and apply the height, which is 2100. That's fine for door opening. And come and say what? Okay, your door will appear here too. The same thing, opening will appear here. So with this now, can I see what we've just done so far? We have now modeled, you can see it, right? We have now modeled for this. Let's now begin to do what? Insert our slabs, okay? That's fine. So on this now, let's now move into slab insertion. So I'll come now and click on it that says what? Back to our plan view here. Now on this plan view, knowing that we have several types of slab, beginning from normal solid slab and then cantilever slab. Now on the cantilever slab, you can see that we have several shapes from semicircle and other kind of shapes, okay? I will show you all that. Let's now go and model for the normal slab, okay? Now for the normal slab now, if I click on my slab icon here under modeling here and slab icon, the next thing now it will actually do is to define my loading load cases, which is to apply load combinations, okay? Now knowing that this building is a 4-story building, some parts are 5-story building, we are going to apply what? Apply a wind load. Knowing that wind load is being applied at a level, once your building is up to 10 meters high, you are going to apply wind load. But in this case, this building is more than 10 meters high, knowing that it is some part are 5-story and some part are 4-story, and the headroom, which is the height of each floor, is minimum of 3.4. So 3.4 multiplied by 5, that gives almost 20 meters height of building. So that's already way too high, and we are meant to apply wind load on that structure. Okay, that's fine. So with that now, I will come now and do what? Apply what? Yes, and say yes. So in this case, it will not display this place for me. I will just come and say what? Loading generator here. Okay, that's fine. Now on this place now, we have vertical load combination, which is, I'll leave everything here as it is as default. No, don't click anything. Then come now on this place that says what? Horizontal loading combination, where you can add your seismic load and wind load. In this case, this building is in Nigeria, so I'm not going to add any seismic loading. But had it been this building is in somewhere like Japan or Japan, Albania, Jamaica, and all that, we would have added seismic load. Okay, that's because earthquake happens in this country, Lebanon and all that. Italy, yeah, would have added seismic load. But in this case, we are not going to add seismic load because Nigeria doesn't have any seismic effect. Okay, but we are going to apply wind load. Okay, that's because the height of this building is what? Is already more than 10 meters high. So with that now, I'll then come here and then check what? Wind load. Wind loading, okay? That's fine. I'll then come here and then click on what? Okay. So with this now, it will create a loading combination for me here, also applying wind load combination. You can see that right now. So you can see these are the loading combinations, okay? That's fine, which will be used for the structural analysis and design, okay? I'll then come now and click what? Okay here. So on this okay right now, the slab this is now display here. On this, I'm going to impute my slab depth minimum. Now, Eurocode or BS code says that the minimum depth of slab is what? Is 150. If you're using Indian code states that the minimum depth of slab should be 4 times the bar diameter. Okay, that's at least 4 times the bar diameter should be your minimum depth of slab. Okay, that's fine. So in this case now, I'm going to come here and then put here that says what 150, since I'm using Euro code for my design. Okay, and then once I do that right now, I'll maintain my concrete cover as 25. Okay, that's fine. Then I'll now move on to the place that says what load. Now on this load now, automatically the self weight is there for you. That's because the self weight, once you impute your depth of slab, sorry, your slab thickness, then the dead load is there. The self weight is there for you automatically. You can see that the self weight now is what 3.75. If I change this now to, let me say, 200, you can see that it will also have impact on this. Okay, so what governs the self weight basically is the depth of the slab you are putting. So in this case now, back to 150, that's fine. So I'll come now and then begin to impute my load now. Now for this dead load now, this dead load is to you have to impute this dead load without factored load. Don't factor the load into this place, okay? Knowing that we have factored and unfactored load. Factored load is when you have multiplied the load you are applying by the factor of safety that comes from each code. In terms of BS code, the factor of safety for dead load is 1.5 GK. So GK is the load that you're going to apply. So now, since we're using Eurocode says 1.35. 1.35 multiplied by what? GK. Okay, so right now this is not a factored load, it is unfactored load you are going to apply here. And how do we get our unfactored load? Factored load is that the dead load basically right now. The dead load for the factored load this dead load here is gotten by the combination of finishing load and partition load. Now, finishing load can vary from 1.0 to 1.2. Okay, now partition load can vary from 0.5 to 0.75 or 1.0. Okay, now depending on what you choose there, when you add those two values together, that gives you what? The actual dead load. Okay, now if you want to consider any other dead load, you can consider it and then put it in here, but don't factor it. So in this case now, since this building is for residential building and structure, I'm going to use a finishing load of 1.2, okay, and I'm going to use a finishing load of 1.0, yeah, because it doesn't have much finish of 1.0 and a partition load of 0.5. So if I add that up together, that gives me what? 1.5. So I'm going to put my dead load here as 1.5. Okay, that's fine. Then in the case of imposed load, just right click on this place, you will see several loads here. Now, since I'm designing for a residential building, okay, I am going to choose the general domestic use. Okay, that's for general residential building. Okay, I'll choose this. If you're doing for hotels or anything, you can see other loads here, hospital and all that, offices, okay, classroom. But in this case, we are designing for residential building. So I'll come now and click on what? General domestic use. Okay, that's fine. So in this case now, once you have imputed these two values, you now begin to do what? Insert your slab on your panels here. Now come back now, you can see that they have slab insertion options, which if you click here, you will see several options here. Now, I'm not going to explain much options here, but just look at what I'll do right now. I'm going to choose beam region. That's because I have beams around, okay? So since I have beam around here, I'll come now and click on this place here. It will insert for me the slab here, okay? So you can now see on our 3D view here that we have just done our first slab insertion, which you are seeing here. Let me just show you. Yeah, correct. So this is our first slab insertion. I can see that. Okay, so we are going to repeat the same thing now for other panels. Okay, that's fine. So on this now, I'll then come back and click back on the slab, okay, to take my property of that slab, okay, because they are all the same since they are having the same load. So I'll come again now and click here. Following, I'm still using B region, okay, that's fine. So I'll click that one there, and the same thing now. Make sure I click on all the panels to put in my slabs, okay, that's fine. Okay, that's fine. Okay, so I click again and click again. That's fine. I click here also to put in my slabs. Okay, so make sure you click on all the panels to put in your slabs. Okay, that's fine. So with this again now, let me see. Make sure I click here to put in my slab. Make sure the slab is there. That's fine. And again, continue again to other. Okay, let me finish up this other side here. Now, since this is a lift, make sure you leave it void. Okay, so don't put slab, don't insert slab in on the lift. Okay, because lift is gonna be inserted here. So leave it as void, and also the staircase too as void. Then come here and impute this here. Okay, so wherever you see these panels, this P and all that, make sure you put a slab there. Okay, we also have a slab around the staircase here, but I'm not going to use a beam region, which I'll show you what to use next. So I'll just focus on the place where we have beam right around. Okay, and where we are seeing all these P1, P2, and all that. Okay, and then putting all our slabs on that area. Okay, that's fine. So with this now, I'll then come again and then insert other ones here. Click here. Okay, and then click this other one here. That's fine. Okay, that's fine. Come now, make sure I put my slab in here. Okay, that's fine. So I'll just repeat the same thing for all other panels and make sure I put my slabs on them. Okay, that's fine. So I'll then come down and then put in my slab here, which is the last one here. Okay, that's fine. So we have now modeled all the slabs around the beam region. Okay, the next slabs that we'll have to model right now are the slabs that we'll have for the cantilever and for other slabs that are having different shape, like for this one here on this terrace that has a kind of shape here, which I'll show you that too. Okay, that's fine. So, and also this other slab that we'll have here too. Okay, that's fine. So the next thing now to do now is to let's now look at the 3D view of what we have just done so far. If all the panels are having slabs, okay. So on this 3D view right now, which is about to open, let me just see right now. Let's see. Okay, we are having a slab here to put here and a slab. Okay, that's fine. So you can see what we have now. Okay, we have a partial slab here around this place and also around this place here. So you can see what we have now. Right now, let's now get a model for that. Okay, let's get a model that right now. So I'll come here and click here now, and then I will then come now and then let's now put slab here. So I'll come here now and take this slab properties just now. Come properties here. The slab start directly from this other side and go here. So I'll come now and change this there's a pick point. Okay. And then I have to pick this point here. Correct. That's fine. And again, once that point appears, I'll come again here and pick the next point here, which is here. That's fine. And again, that will be point 2, which you are seeing here now is showing axis 45. That's point 2. Now point 1, point 2. So I'll have to make sure I pick all the 4 points that will have this slab here. So I'll come again and pick here. This is point 3. That's fine. And once I pick the last point, which is point 4, the slab will just insert here automatically. So I'll come now. Okay. And then come and pick here as slab 4, sorry, point 4. That's fine. So you see the slab will appear here now, which is slab 15 will appear here on this B15. That's fine. So on this case again now, let's now go again and then go and insert on the other side of the staircase. Okay, that's fine. So with this now, let's now come here. Now before I begin this other one here, I must make sure I clear this here. Okay, then come now and then click on this. That's fine. And again, come again here, and then click on this one other here too. That's fine. Click on this too. Just repeat the same thing. Okay. Come again and then click here. That's fine. And again, the final one here, which is this other side here, and click here too. That's fine. So with this now, the slab will appear here. Okay. I'll then come. Okay, the final one here. That's fine. The slab will appear here now. That's okay. Let's see. That's fine. So you can now see what we just have right now. You can see what we have right now. So we have now this slab here. Let's now check out on the 3D view again to how this place looks like now. So let's now go and see this other side now. Let's see. Can I see what's happening right now? You can see. Yeah, so this is what we have now. So this place now becomes a staircase. Okay, the staircase here. And again, this other place that becomes the staircase. Now the whole reinforcement for this slab here will be anchored on these surrounding beams. Okay, And also the same thing here surrounding beam. This is not a cantilever beam, okay, because it has all the three edges supported, okay, by beams. Okay, that's fine. So with this again, now back to this last place now. So let's go and see now what you just do right now. So back to the plan view right now, you can now see what we just got. Okay, so the next thing now is to now begin to, now before I begin to show you this other side of how to model this other beam slab here and its load, cantilever loading. Let me just dive into the pin pin to pin end. Okay, so basically when you're seeing after a modeling like this, all the beam ends are considered as fixed on this software. So it is right to apply pin end on all the ends of the beams except the places that are continuous. All continuous points on the beam or joints are meant to be fixed, but all other ends of beams are meant to be a pin end except the cantilever ends. Cantilever ends are naturally fixed ends. Okay, that's fine. So with that now, I'm going to apply pin end on these two ends of beam. Okay, so I'll come now and apply pin connection or pin support. Okay, so I'll come now and apply hinge. Come here and say hinge both ends because both ends are free. Okay, that's fine. You can see that circle 0 will appear here, which simply means that I have removed the moment on this beam at the ends of this beam. Okay, that's fine. You can see 0 have appeared right now. So I've made this pin to be a pin end, and knowing that moment at pin end is equals to what? 0. Okay, that's fine. So again, I'll come again now and click on this. This is still an end to end. Okay, so I'll come now, right click here, and then come here and say what? Both ends. Okay, that's fine. Then this other one now, this other one here, which you're seeing here, I'll click on this right now. Click on this, right click here. This is not both end, but this is just a single end, which is this other side here will be pinned. Here will be fixed because it's a continuous end. So I'll come now, I click here and say what, and then say J, and J is the up, okay, and say pin. Okay, accepted. Sorry, add selected beam. So you can see the circle will appear here. You can see the circle appear here. That's fine. So you can see that we have zero moment here, 0 moment here. Okay, that's fine. So it's a reduced moment. Okay, that's fine. So you can see I will then come now, this other side now, and then make it also what? A pin end. Okay, pin end, hinge at I, which is the left. Okay, apply. There will be a zero moment here. That's fine. You can see there. You can see right now. That's fine. So with this now, with this concept, I'm going to hinge all my beams. Okay, or just as I've shown you right now. Now, if you want to know more about hinging, we have done a comparison between what will happen when you don't hinge and when you hinge. All right, we have done a comparison and we have shown real life example what will happen to a beam when you don't hinge it, and what will happen to a beam when you allow it fixed as it's there. Okay, that's fine. You will see what will happen. So if you want to get that, we have that video already on our channel here where we made a comparison of what happens. Now the title of the other video is what happens when you don't hinge when you don't apply a pin end on your beams or on your structures. Okay, that's fine. So with this now, I'll then apply pin end on all the beams. There is no automatic way to do that, but you can select each of the beams that have both end and hinge them at once, which I've done on most of our videos. So with that now, I'll pause this video and then complete all these procedures. Okay, that's fine. So right now, you can see that I have released all the moments from the ends of all my beams. Okay, you can see right now. You can see that I have released moments. You can see they are all 0. Okay, all the beam ends are all 0 moments. That's because I have released them. Now, have the culture of releasing moments at the ends of your beams. Yeah, it's really very good. Except you are designing for a seismic structure. That's buildings that's around seismic zone. Okay, that's fine. But apart from that, then it's a good culture to release moments at the ends of the beams. Knowing that you can see right now, I have all released them. They are all 0 moments now at the ends of the beams. Okay, while the continuous parts are still fixed. Okay, because there will be there will be a top moment that are going to pass like this here around this place on this beam. Okay, so all the continuous ends, you can see that are still what fixed. Okay, you can see that they are still fixed. All the continuous end for this beam now, for this beam, you can see that for this beam, this continuous end here along this horizontal side is still fixed. Why this beam now? This is an end, this is an end. Okay, so there's a concept about this. Okay, that's fine. So this we are maybe this is how we can explain more on one-on-one training. Okay, so right now you can see this. I miss this place here, so I need to also make this here to be fixed. That's because an end. This is J end. Yeah, hinge, just pin. Yeah, that's fine. Release it. That's fine. That's okay. So you have to make sure you look. Okay, make sure you look very well to make sure that everything is okay. So you can see what we've achieved today now. Okay, that's fine. This is almost 15 minutes. Okay, which is, I don't want this video to be up to 1 hour. Okay, so that you that are watching, you do not get tired. Okay, know that this is a continuous part until we are done with the whole structure. Now let me show you how this structure will look like, okay, at the end of our design or modeling. Okay, now let me show you. Now you can see this is how this building will look like when we are done with the whole modeling. Okay, you can see the target. So this is the target of what we are about to design. Okay, model and design, right? Yeah, so you can see it, right? You can see the difference in foundation. You can see that, right? So this is how this building will look like. You can see the cantilever beam slabs. Okay, you can see how they are curved. You can see the load on them. So this is what, and also this other side. So you can see how these ones are also covered and also framed. Okay, so this is our next mission, is to insert these cantilever slabs you are seeing here, and also load it, which I'll show you. Then insert our story. Okay, model our foundation beams and the slabs. Okay, then we will then insert other stories and then move into the structural analysis. Okay, so we have just less than 4 parts to complete this structural design you are seeing here. Okay, now that, okay, so you can see what the end product of this you are following right now will be. Okay, so please follow to the end of this particular part of this training series, okay, for you to gain all what you are seeing here, okay, on my screen. So thank you so much, and God bless you. Now if you have not yet subscribed to our channel, please subscribe to our channel Ekidel, okay, and also give this video a thumbs up, and also recommend your friends and colleagues to Ekidel, because it's only by doing that we will be able to help the future civil and structural engineer by spreading the knowledge around the globe. Thank you so much, and God bless you. Ekidel loves you, and I love you. Bye for now, and see you on the part 4 of this video, which is to now model the cantilever slab which you just saw on the previous slides, okay, or clip. Okay, that's fine. Thank you so much, and God bless you. Bye for now. We love you. Bye then.